of your equation of motion. All right. Now we have some importance. Since we need to explain a little bit, I will focus on again explaining the equation of motion and also its solution in terms of the physics, rather than just talk about the math. All right, and then let us look at this example. This is the example, and they have two roots. It's gamma 1 equals to minus 1, and gamma 2 equal to minus 2. This is non-repeated roots. Gamma 1 equal to minus 1, gamma 2 equal to minus 2. All right, most of the dynamic system, they are non-repeated roots, as in most dynamic system. So its general solution is very simple. It's C1 E gamma 1 t plus C2 E gamma 2 t equal to C1 E minus 3 plus C2 E minus 2t. Okay, because they are distinguished. The roots are non-repeated. Because the roots non-repeated, you can write in terms of C1 E minus t plus C2 E minus 2t. Now, what is the significance of these solutions? C1 minus t, let us look at this. E minus t, if you plot the curve, it's just like that. It's from 1, assuming it's from 1, and then it coming down. T equal to 0 is 1, and t come down to about 6 is almost 0. C minus 2t, so minus 2t, if this 2t, then it decay much quicker than the E minus t. So what is the physical meaning of this? Look at this minus here. You need to look at this minus here. Minus. All right. If my dynamics behavior like this, say I have initial is 1, and then I quickly going down. This is like a damper, right? If I have a damper, and it behaves like E minus t, then my damper will absorb the energy quickly from your motions. That means I want to have minus 2 or minus 3 or minus 4. This minus 2 term, the minus term is more than I will have the motions will damp up quickly. So exponential minus, and also this 1 and 2 is the real roots. We look at the real roots. How about if we have a complex roots? Then what's going on? This is the real root. Okay, the complex roots. See? So I need to explain the complex roots. If I have gamma squared plus gamma plus 1 equal to 0, then I have two roots. Then I have gamma 1 equal to minus half plus I square root 3 divided by 2, gamma 2 equals minus half, minus I square root 3 over 2. All right? Then that's the solution you have. Watch. You gotta watch carefully about this. Look at this. Roots has imaginary I. Imaginary I in physical world does not exist imaginary sense in the physical world. So, when you write in terms of this, and you have I here, the best write the best way is writing in terms of this. C1 cosine square root 3 minus 2t plus t2 sine cosine 3 over 2t, because they are not imaginary involved. So your solution y, you're supposed to write in terms of this way, because this one has a physical meaning. The I here, imaginary. The I here just gives you some mathematical convenience to solve the equation of motions. So you learn, everybody here learn a complex variable before? You do, right? Have any course? Did you take any course complex variables? The complex variable only serve as a tool, the mathematical tool, but physically just don't have meaning. Okay. So that is the solutions. Look at this carefully now. The next one is more important. Look at these two curves. I have a e minus half t, and the same thing e minus half t. The e minus half t gives you what? Gives you the damping. Cosine here gives you the oscillations. Give you the oscillations. If you recall, about 2 slides ago, if you don't have a sine function there, it decays just from 1, decay quickly to 0. Here, you decay down and you go up and going down. The same thing is going up, going down, and going up. And this is because you have cosine, you have sine, and square root of 3 divided by 2, that's your oscillation frequencies. Okay, listen carefully now. If you look at the that one here, the real powers of eigenvalue give you the damping. Could be negative damping, can be positive damping. An imaginary power of square root of 3, 2 give you the frequencies. That's the real, that's the physics of this eigenvalue, of these roots. All right. So, well, let's take 10 minutes off. Then I continue to explain some physical meaning of the roots.